Is the universe infinite? The surprising truth about cosmic geometry.
Measurements of the primordial universe reveal that space appears flat everywhere we can observe.
However, beyond our cosmic horizon, the universe may curve, loop, or connect in unexpected ways, leaving open the ultimate question of its size and true shape. When we look at the sky with powerful telescopes, we see galaxies, stars, and structures that extend as far as light has traveled since the Big Bang. This is our observable universe, an immense bubble tens of billions of light-years in diameter. Astronomers assume that the cosmos continues beyond this boundary, with more galaxies and matter extending outward, but a profound question arises: what is the total size of the universe, including the regions we will never be able to see? The truth is, we may never know the complete answer. All we can do is speculate based on what science has already discovered. The universe may be infinite, extending forever without end, or it could be finite, but without any edge, something that seems paradoxical at first glance. Think of the Earth's surface. It is finite, but it has no edge if you walk only on it. You can walk in circles forever without falling off a boundary. The Earth can do this because it is curved. Something similar happens in the universe if space is curved in the right way. It can be finite and, at the same time, have no ends. To find out if space is curved or flat, scientists use simple mathematical tools, similar to those that measure the curvature of the Earth. In a perfectly flat space, the internal angles of a triangle always add up to exactly 180 degrees, and parallel lines never meet. On curved surfaces, the angles of a triangle can add up to more or less than 180 degrees, and parallel lines end up intersecting.
Astronomers apply these same tests to the entire cosmos. They observe the light that comes from the very young universe, released when the cosmos cooled and ceased to be a hot plasma. This light forms the so-called cosmic microwave background, a radiation that fills all of space and carries impressions of the primordial universe. Calculations show that there should be small temperature variations in this cosmic background, and indeed there are. Furthermore, it is possible to predict the expected size of these variations. If the universe were curved, the light would have traveled along curved paths for billions of years, altering the apparent size of these spots. By comparing the predictions with actual observations, scientists discovered that the spots are exactly the size expected for a flat universe. This means that, on the scale of what we can see, space is flat like a sheet of paper. But does this prove that the universe is infinite? Not necessarily. Imagine trying to measure the curvature of the Earth by looking only at your backyard. The triangles would be too small and the parallel lines too short to reveal any curvature. Similarly, our observable universe may be just a tiny piece of something much larger, where everything appears locally flat, but the entire whole could curve on gigantic scales.
Another fascinating possibility is that the universe is geometrically flat, but topologically closed in some dimension. Take a flat sheet of paper and fold it into a cylinder. The triangles still have angles adding up to 180 degrees and the parallels don't intersect, but now space has a dimension that curls back on itself. There are several such shapes like cylinders, tori, donuts, Mobius strips, and other more exotic structures that maintain flat geometry but close space in loops. In 3 dimensions, mathematics knows of at least 17 different topologies that are geometrically flat. Scientists have already looked for signs of these curled shapes, such as repeating patterns in the cosmic microwave background or galaxies appearing on opposite sides of the sky. So far, nothing has been found, suggesting that the universe is flat and simple, without detectable curls. Even so, the question remains open. Due to the accelerated expansion of the universe, very distant regions are receding faster than light, making it impossible to observe them someday. Curvatures or curls on scales larger than our horizon may exist forever beyond our reach. Therefore, the universe may be infinite, going on and on without stopping, or it may be finite, curved or curled in ways we will never see. Cosmic geometry shows us a flat space as far as we can study it, but its ultimate shape and size remain one of the greatest mysteries of science.